Let's go on. So this presentation is about successfully using signals, and for this I have prepared 3 effective rules for you. And if you follow those rules, using signals will be a bit more straightforward for you. I want to get started with some pictures. You know, I live in Austria, and when people think about Austria, they mainly think about nature. You know, we are this country in the Alps, we have a lot of mountains and a lot of nature. People like to go skiing. However, there is also a very serious topic people think about when talking about Austria, and the serious topic is Sacher cake. Sacher cake is one of the special desserts we have here in Austria, and we have quite more here. And this is what this whole presentation is about. It's about Sacher cake and further Austrian desserts. And besides this, I will also talk about some stuff in the area of signals from the perspective of an architect, from the perspective of someone who makes using it simpler and more streamlined. So it's about computed signals from this perspective. It's about effects. It's about the RxJs interop, and it's about stores. The result of all of this is 3 rules. So I'm distilling out 3 rules of this. You know, here in Austria, we distill a lot, and that's why I also like to distill out some rules. And I have 2 hints for you. Before we get started, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I and also my nice colleagues focus on Angular in the enterprise. In this role, we are doing a lot of consulting and a lot of trainings. I'm also quite connected to the Angular community. I live in Austria, where we have Sacher cake. I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the globe. We have a lot of customers in the Switzerland, also in Poland and in other parts of Europe. Okay, so let's get started with Austrian desserts. Austrian desserts is actually my example application. So let me quickly start it up. It's already started, yeah. It's even better. It's my example application. And here we go. Yeah, here we have our Austrian desserts. And yeah, in this application, you can find out a bit about all of them. You see pictures of them and you see the names. We have here the English name and we have the Austrian German name of all of them. And the most important thing is you can rate those desserts. You can say, well, Sacher cake is okay. Apfelstrudel, apple pie is also quite nice. But trust me, the best of all of this, the best is Palatschinken, which is our way to refer to pancakes. In German, you have different names for this. In Austrian German, we call it Palatschinken. And I did some research. I found out that Austrians borrowed those names from the East, from Eastern Europe, and it landed there from Latin. And basically, Palatschinken means cake, so it's not a bad name, I guess. And yeah, Palatschinken is really nice. It gives me a lot of memories from my childhood where my grandma baked them for me. Usually we eat them with jam. But if you want to go pro, if you really want to go pro, you eat it with ice cream. This is by far the best. And here, 5 stars out of 5 stars is not enough. And that's why I've implemented a cheat mode. Click here. If I'm double clicking the star, then I can select up to 500 stars, which is quite a number. 500 stars out of 5 stars. When it comes to ice cream, pancakes, mathematics does not count anymore. Okay, cool. So this is one part of the application. Another part is we can search for our desserts. For instance, I can enter cake here, and this gives me a nice filter. and I can load expert ratings, which are my ratings, and then you get my star rating displayed. So more or less, this is the example application. So let's get started to talk about signals and about how to use signals for such an application. And I want to get started with computed. But before we talk about computed, let me quickly tell you 3 or 4 things about signals in general. You know, signals are this new building block in Angular, this new reactive building block. Basically, a signal is a value, and this value is encapsulated in this object. And you can read the value, you can update the value, and after updating the value, you can get notified of the new value in some circumstances. And yeah, this is more or less what we also have with RxJs and observables. But the thing is, it's really simple. It's not as powerful as RxJs, but it's also simpler. And the Angular team wants to give us this building block to get started with something that really comes with very little ceremony. Something that might be okay for, let's say, 80% of the use cases. And for everything else, we can switch over to RxJs. Why do we get signals from the Angular team? Well, it's all about the fine-grained change detection. A signal can tell us and Angular when it is changing, and so Angular knows, well, I need to update this very component here. And this is also one of the keys for zoneless Angular. You know, with Angular 18, we got zoneless Angular in an experimental mode, and zoneless Angular can benefit from signals. It also works with the async pipe and observables, but using signals for it is a bit more streamlined. So if we look at a component without signals, we see, or with signals, we see that we just need to wrap all the values we want to data bind in a signal. Then we can call a setter. The setter is updating the value. And then we can read the signal, for instance, within our template. And when reading the value, we need to call the getter, which is basically the signal with full parentheses. So we don't need to type in .get, just use the signal and full parentheses. One of the nice things here is that if we read a signal in a so-called reactive context, and the template is such a reactive context, then the context is subscribing to the signal. It's automatically subscribing, and so it will get notified when something is changing. That means just by reading the signal in the template makes sure that template and Angular is notified, and so Angular knows when to update this very component. The subscription happens automatically. By the way, also unsubscribing happens automatically. And another nice aspect here is computed signals. It's just a computation that is using existing signals. And one of the nice things is every time one of those used signals is changing, the whole computation is repeated. It's more or less what we know from selectors in the world of NGRX. It allows us to compute our view models, some data structure that is in the form we need for this or that use case for this or that component. So now let's talk about computed in the context of an architecture. And for this, let's switch in my application, into my demo application. If you want to repeat my live coding, you can just check out the branches here from the slides, and then you have exactly the same state as I started off with. Okay, so if we look here into the source code, we see that we have here a desert component, and this desert component is about searching deserts and rating deserts. And there is some criteria. For instance, there is a property original name to search by the original name, and we have the same for the English name. We have here a flag for loading, so that we know when to display the loading indicator, and we have a desert signal which holds our result, a desert array. The first part of this component is not that spectacular. It is about searching our deserts. I'm grabbing my criteria. I'm calling the find method in a desert service, and I'm getting back my deserts. I'm putting those deserts into the desert signal, and I'm also maintaining the loading flag. When it comes to the remaining parts, it's a bit more special. For instance, toRating is combining the loaded deserts with the loaded expert rating. The loaded expert rating here is a map, basically a map that is projecting the IDs of our deserts to the rating. This means that desert 1 gets 5 stars. Or here we would say desert 2 gets 4 stars. And so on. Yeah, and everything is intermingled here with each other so that the rating is reflected by the desert. When we are calling load ratings, we are also loading my expert ratings. Then we combine the already loaded deserts with those expert ratings and update the deserts. And this is somehow strange, isn't it? Because it's all about loading ratings, and even though it's about loading ratings, we need to update the deserts. If we use something like this, we get code that is really hard to be maintained. And it's even harder if we realize that there are, let's say, 5 positions in the source code where we need to update ratings and deserts this or that way. For instance, here we have another position within the source code where we need to update the ratings. This is when we rate our deserts by hand. So always updating the ratings and the deserts is somehow an error-prone thing. And that's why we can really improve the source code with Computed. For this, first of all, let me introduce a signal for my ratings. It's a signal with the type we have seen before, this map type, desert ID to rating map. And we get started with just an empty map. Then, after loading the ratings, let's just put those ratings into our signal. This dot ratings set ratings. So this makes a lot of sense because all of this is about ratings. And then we can compute out of the ratings and the deserts everything we need. For instance, deserts with ratings could be a computed signal. And here I'm just calling toRated. I'm passing in this dot deserts and this dot ratings. So what happens now is that Computed will compute those deserts with ratings, and every time this or that signal is changing, everything is recomputed. So we are always up to date here. We don't need to remember to update this data structure here or there. It's always automatically kept up to date, and our code is more local. When we deal with ratings, we update the ratings. When we deal with deserts, we update the deserts. So let me quickly update my view. I want to iterate through the deserts with ratings. And also here, I want to get the length of this data structure. So let's try it out. I want to have Palatschinken. No Palatschinken. English. Pancake. Cake. Yeah, perfect. And if I load the expert ratings, everything works here. This brings me to my first architectural rule: synchronously derive state where possible. In the world of reactive programming, in the world of functional programming, it's not that usual to update state. We really try to prevent the need for updating state. When possible, we derive state, because derived state is always up to date. However, we need to do this in a synchronous way, because computed only works in a synchronous way. There is currently no async computed in Angular and in the space of signals. So for async stuff, we need something else, and we will talk about this in some minutes. Let's talk about a second thing. Let's talk about effects. So as you might know, an effect is just a side effect using signals, and every time one of the signals is changing, the side effect is repeated. Let's look at this within another demonstration. So in this demonstration, I'm going back to my deserts component, and in there I'm defining a constructor, and this constructor spans up an effect. And first of all, let's just log something out. Let's log out our original name. And let's log out the English name. That means every time the original name or the English name is changing, this effect will run again, and so we get this console output. Let's try it out. F12, F12, A, B, C, D, 1, 2, 3, 4. So everything, one of those signals is changing, the effect is re-triggered. And actually, logging something out to the console is a good use case for an effect. Because in general, effects are for logging, or not logging, for doing some rendering stuff that is not possible with data binding. Rendering not possible with data binding. And I have some good examples for this. A good example is logging, because you cannot log with a data binding. Another example is showing a toast message, or a snack bar, as it is called in Angular material. Another good example is drawing at an canvas. 2D rendering, 3D rendering, and perhaps a fourth good example is writing into a reactive form. All of those are good examples for going with effects. Rendering stuff not possible with data binding. In general, you can say an effect is intended for the last mile between your system and your view. Somehow you want to transport data into your view. Effects, however, should not be used for propagating state. So let me show you an anti-pattern. If I used an effect to bring some state into a service, let's say I had service and update or search, then just using such an effect to propagate the original name in there is not a good idea. And there are several reasons for this. One reason is, if we use effects for propagating state, it's very likely that we are defining reactive chains, where one change is leading to another change, that in turn is leading to a third change, that in turn is leading to a fourth change. And if we have something like this, controlling the system is really difficult. We don't know anymore what happens when we change something here. This is one of the issues. Another issue that is somehow related to the first one is, if we have such a chain, such a reactive chain, we might end up with a cycle. And also hunting down cycles And debugging cycles is really difficult because they lead to an infinity loop and our browser might crash. That's why we are not allowed by default to write a signal within an effect. So if I would say, well, the original name is the same as the English name, because nowadays everything is English, then we would get an exception from Angular. Let's try this out. Here is the exception. Writing to signals is not allowed in computed or an effect. Use allow signal writes in blah, blah, blah to enable this inside effects. So by default, this is not allowed. This is a child safety facility the Angular team gives us, but we can deactivate this facility by allowing signal writes. Then something like this is possible, but then we are responsible for making this safe. This is perhaps like a typecast. First of all, the compiler says, no, this is not a possible cast. But if we do an explicit typecast, then we are telling the compiler, hey, we know what we are doing, we are experts, but then we are responsible if something goes wrong. And as you see here, now my two fields are synchronized. See this as the last resort. You should really avoid signal writes or effects propagating the state. You also find this statement in the official Angular documentation. It might be the case that when migrating existing codes to signals, that you need to go with something like this. But if you start writing new code or if you have some time, then please avoid this. Instead of doing something this, you can totally go with computed by computing one out of the other signal. So let's comment this out. This brings me to my second rule, namely avoid effects propagating state and signal writes. Let's talk a bit about the RxJs interop. I already told you before that signals are really great. They are simple and they are suitable for, let's say, give or take 80% of the use cases. For the remaining use cases, you need RxJs or something else, but usually we go with RxJs because it's really powerful and we have experience with it because it's baked into Angular, isn't it? And so it's really good to know that you can convert each and every signal to an observable and vice versa. So let's have a look into an example for this. For this, let me quickly jump over to my branch 05A, no, 05B. And here, now I have a reactive version of this application. We don't need a search button anymore. I just need to type in some letters and when I'm doing nothing for some milliseconds, then my result automatically appears. Check. So to implement this, I'm using two functions from Angular core RxJS interop. It's to observable and to signal. To observable converts a signal to an observable, and to signal does the other way around. Still, I have here my original name signal and my English name signal, but here I'm converting it to an observable, and then I'm using the magic and the power of RxJS. Stuff like combining both streams, filtering, debouncing, switch map, and also error handling. And something like this is really difficult to accomplish without RxJS. Implementing a debounce time or a switch map by hand is nothing I want to do because it's error prone and it's infrastructure code. It shall be done by someone else. Saying this, as you know, switch map and all the other flattening operators are also wonderful because they give you guarantees in terms of race conditions. So let's assume we are searching for A. And before we got the result for A, we are switching so that we want to search for B. And before we get the result for B, we are switching again so that we want to search for C. Switch map will only give you the last result. Everything else will be aborted, which is what the user would expect when searching by criteria and when changing the criteria. The user would not expect that the result of A is blinking for some seconds, so that the result of B is appearing for some seconds, so that this result is replaced by the result for C. This would be bad UX or UI. And yeah, switch map takes care of this. Switch map gives you some guarantees for overlapping requests, and that's why it's also quite valuable. As you see here, we can also convert back an observable to a signal. This brings me to two hints I want to give you. The first hint is signals play well together with RxJs. You can really have the best of both worlds. And the second hint is avoid race conditions, and RxJS with switch map, exhaust map, and so on really helps you nicely to do this. Let's talk about a last thing. Let's talk about stores. And before I want to talk about stores, I want to show you this nice, good old video game, The Incredible Machine. Perhaps you know it, The Incredible Machine. It's about producing a side effect that leads to an side effect that leads to an side effect. So let's have a look here. The bowling ball goes down, it triggers the cannon that is triggering the balloon, and so on and so forth. So it's really a fun game to find out how to arrange all those items so that you get your final side effect. But honestly, if your application looks like this, you really have an issue, because then your application is not maintainable anymore. Then you don't know anymore what happens when you change something here. And one way to prevent this is the good old unidirectional data flow. And stores can streamline this unidirectional data flow. Here I have a quite abstract perspective on a store. It's about a component that has some intention. It wants something to happen. And this intention is sent over to the store. In a Redux-based store, the intention is about triggering an action. In a more lightweight store like the Signal store, the intention is just about triggering or calling a method. But at the end of the day, somehow you tell the store what you want to happen. It's about the what. This is what I'm calling intention in this abstract perspective. The store is then performing some tasks, and this could also be an asynchronous task. For this, the store could use RxJS. RxJS is quite good at doing async stuff. And after this task is executed, we get new values. Those values are put into a signal, and the signal now transports these values into the components, or to be more precise, into the view of your components. And this happens in a synchronous way. And when doing so, we can project the values using computed to our view model, to the representation of our state we need for this or that view. You might have deserts and ratings. Sometimes you want to combine both. Sometimes you want to have the ratings without your deserts, and sometimes you want to have your deserts without your ratings. And here you can compute everything together in the structure you need. So I think the key takeaway of all of this is that signals are mainly suitable for the right side here, for synchronously transporting values into your view and for synchronously projecting your values. Signals are not suitable for async stuff, and signals are not suitable for defining an intention, because this is most of the times about listening to an event, and signals are not intended for events. So you need other stuff for the remaining parts, and this other stuff can be a store and or RxJs. So let's have a look at a demonstration for all of this. Let's check out the branch. Here in this example, I'm using a very simple store. It's a handmade store. So store is quite a big name here, but basically my store is just a service that provides some methods and some signals. That's all. And as you see here, I'm grabbing those signals from the store without parentheses. I don't want to have the values. I want to have the signals. Those signals are data bound. And then I'm calling some methods in the store. And as you see here, the intention goes up. The intention is load deserts. Something happens there. And when the deserts are loaded, they are put into my desert signal and everything is flowing down. Perhaps the desert signal is also combined with the rating signal. There is some computed signal there. And so I get my rated deserts. And it's similar when I want to update my ratings and so on. The intention goes up and the result of the action goes down. So as mentioned, you don't need a store library. Of course, there is the great NGRX store, the Redux-based one that supports signals. There is the brand new NGRX signal store. It's also a very nice implementation. I would recommend to look into it. But at the end of the day, just going with a service, providing methods and signals is good enough. And this brings me to my last architectural rule, namely stores make your reactive flow more manageable. So if you like this presentation, you will very likely also like our ebook. It's a brand new ebook. It's currently in the second edition, and it's about modern Angular. Here we talk about all the things, signals, how to use them correctly. We also talk about the new control flow syntax, the variables. We talk about how is it called? I just lost it. About standalone, yeah, standalone components and standalone APIs. So it's full of those modern stuff we got recently in Angular. So download it here for free. Also, if you are interested in this stuff, have a look into our workshops. We are doing the English version of this workshop in about a month. It's end of July. So go to our website and book your ticket there. Let me come to a conclusion. Basically, we've talked about 3 architectural rules. One rule is synchronously derive state where possible, and we use computed for this. The second rule is avoid effects propagating state and signal writes, because then we might end up with an incredible machine where one change leads to another change, leading to a third change, and so on. And think about using stores, because stores stream align your whole flow and they make everything more manageable and predictable. And finally, those rules are enforcing each other. Just let me give you one example. To avoid effects propagating state, you can derive state synchronously, and you can use stores for the async stuff. Very likely stores use RxJs underneath the cover. And this brings me to my 2 hints, namely signals play well together with RxJs and avoid race conditions. And also here, RxJS does a great job with switch map and exhaust map and so on. And last but not least, please remember that ice cream pancakes, Eisballerschinken, is the best dessert in Austria. So if you come to Austria, then all you need is to know the term Eisbaratschinken, and you will be on the same side. Give it a try. So thanks for having me. I have already uploaded my material to my blog. You find my examples there with several branches and my slides. And follow me on Twitter to stay in contact. Thank you.
Thank you, Manfred, for your awesome presentation. Let's see the questions. I have number of checkbox in table. Then how to manage state of checkbox, checked, unchecked, select all state with signals. It's like some specific question.
Yeah, so the good message is, meanwhile, you can directly data bind a signal using ng form, and you can even go with a two-way data binding. So the banana in the box syntax is meanwhile fully supported for signals, and this might be one option. Of course, if the value comes out of a store, then the value might be read-only, because usually we don't want that everyone is capable of updating our state. We want to update it in a well-defined manner, don't we? And in this case, you might want to go with reactive forms, and then you can just write the contents of the signal into a reactive form. And when you save it away, or if you just change your form, then you can send up the changes to a store, for instance. So those are, I think, two good possibilities for doing something like this.
Okay. There is another question. What do you think about signals and forms for the future?
Yeah, so currently we have some support. I mean, if we stick to reactive forms, not much is changing. The only thing that is changing is that now the source for our form group and form control is a signal. But eventually we will get more support for forms. The Angular team is thinking about updating the form support for signals in the first phase, and rumor says that might already begin this year. In the first phase, they want to add signals to the forms API. And in a second phase, they might think about unifying our two form models to just one model of using forms. So perhaps we get something that combines reactive forms and template-driven forms.
Okay, that's awesome. There is another question from Marcus. Would you say that using untracked in an effect would be a good solution to bypass allow signal write, or is that cheating?
No, so I think it's even better than using allow signal writes. If I have a bit more time when doing this presentation, then I'm also showing this pattern. I think it's meanwhile quite a pattern using effect with untracked. So I think it's the way to go. And I think you can avoid it quite often with the patterns I have presented today, but not always. There are still some remaining cases where you need an effect propagating state, even though we all know we should avoid it. But sometimes that's not that easy to be accomplished, because sometimes we just want to use the signal we already have. And Angular provides more and more signal-based APIs. We don't want to bypass them. So it might feel a bit more natural in some cases. And yeah, for those cases, effects with untracked is a good solution.
Okay, we'll pick two last questions. So when should we use Redact-based store and when should we use signal store? Additionally, is it recommended to use the Redact-based store and convert selectors to signals?
Yeah, so that's actually a good question. So I think if we look back, let's say 5 years, then the Redux approach was the go-to approach for stores. Most people used some Redux-based store 5 years ago when they used the store. Meanwhile, I think people have found out that Redux is really cool, but sometimes it's too much. There are use cases where Redux is just too much. And those are use cases where each and every component has its own state. It might be global state because we might need it later again, but it might to be bound to one component or let's say one feature. And in those cases, Redux does not really help that much. However, if we have a lot of components that need to access the same state and a lot of the same state, then Redux is really king. So in those cases, I would stick to Redux. In other cases where a feature has its own global state, I would use a more lightweight store. And I think people are thinking more and more if they need Redux or if something more lightweight could be suitable. If we look into other framework communities, this is also the case there. Solid.js comes with a lightweight store. In Vue, we have some lightweight stores. In React, it's also quite usual to use lightweight approaches meanwhile. So this is the first answer. The second answer is
whether it's recommended to use the Redux-based store and convert selectors to signals.
yeah, so the good message is you don't need to do this because the Redux-based store, the NGRX store, has now a method that's called select signal. And it just gives you back a signal. You can pass in your selector and you get back your signal. And that's actually a good message because if you have already invested into Redux, if you have already invested into NGRX, the traditional store, all you need is to switch out the select method by the select signal method, and you have your signal for data binding.
Okay. And the last question, signal is fine-grained change detection. Does it mean it will only trigger change detection cycle for specific component without the whole tree?
Yes and no. So currently it's somewhere in between. Eventually we might get there, but currently, if we let's say use on push and signals, then Angular will mark the affected component as dirty. However, as on push still climbs down, top down the component tree, all the parent components are also marked. They are not marked with 30, but they get another marker. And so Angular knows that it needs to go down there. It knows that it does not need to check the components in between for changes, but it knows to go down there to find the dirty component eventually somewhere in the leaves or somewhere down in the tree. So it's somewhere in between, but perhaps eventually we might get there, perhaps with signal components that we directly jump to the locations where we need to update something, or that we just need to update a portion of a component, which is also one of the visions of the Angular team, to find out that we just need to update this right side of the component, but not the left side of it.
Mm-hmm. Okay, so that was the last question. Thank you, Manfred, for your time. It was an honor to have it with us today. And we are looking forward to have you in the future meetups. And have a nice day. Get your rest.
Awesome. Thank you.
Yeah.
Have a nice day. Bye bye.